So hello students. So today we are going to discuss about the preparation of aldehydes and ketones. Before this, we have discussed already IUPAC nomenclature, how to write the IUPAC naming of aldehydes, ketones, carboxylic, and derivatives. And also we have discussed about the structure of the aldehydes, ketones, and carboxylic acid. So today in this class, we are going to discuss preparation of aldehydes and ketones. Some preparation method already you have done in the previous chapter. That is what? First, oxidation of alcohol, or we can say dehydrogenation of alcohol. Oxidation of alcohol, okay, so you can see when primary alcohol, that is RCS2OH, oxidized in the presence of PCC, this CS2OH group directly convert into CHO. So when we get from 1 degree alcohol to aldehyde, we have to add mild oxidizing agent like PCC. PC is the mild oxidizing agent. What is the full form of PCC? Pyridinium chlorochromate. Okay. If we add very strong oxidizing agent like this in this primary alcohol, if we add KMNO4 as a strong oxidizing agent, then in this case, instead of aldehyde, what we get? Carboxylic acid. So for preparation of aldehyde, we have to add PCC in 1 degree alcohol. Or also we can add copper catalyst at 573 Kelvin. Or we can add silver also. But silver is very expensive, so better we prefer copper. In case of secondary alcohol, okay, all of you know, in secondary alcohol, FPCC or copper 573 Kelvin or even KMNO4 also added strong oxidizing agent. Also, in that case, the secondary alcohol always get converted into ketone. So secondary alcohol always oxidize into the form of ketone, like this is. Okay. So what do you mean by oxidation? Oxidation is basically what already we have discussed, that is removal of H from carbon. This is alpha carbon and hydroxycarbon, alcoholic carbon. Okay, or we can say alpha carbon or alcoholic carbon. So one hydrogen is removed from alpha hydrogen and second hydrogen removed from alcohol. So we can get ketone. So remember this thing, the 1 degree alcohol forms aldehyde, 2 degree alcohol forms ketone in the presence of PCC or copper 573 Kelvin. So this is the first method. Second method, from hydrocarbons. In hydrocarbons, we can study about hydrocarbons means what? Alkenes, alkynes, toluene, etc. So from hydrocarbon, it is again 2-3 methods. That is, the first is a hydration of alkynes, which I have already read in class 11 and even the chapter 1 also, that is aldehyde, haloalkanes and haloarenes. Okay. So in this case, what we do, what is the reaction in this case? Hydration of alkyne. So alkyne, we can take one example, that is ethine. So when ethine reacts with water, or when ethine undergoes for hydrolysis in the presence of mercuric sulfate, catalyst, and sulfuric acid, dilute H2SO4. So the reaction what occur? OH minus and H plus will be added at the carbon. Okay, this is a symmetrical alkyne. So anywhere we can add, suppose at this carbon, hydrogen H plus is added, and at this carbon, OH minus is added. So there is a formation of enol, and you know enol is not stable. So to stabilize, it undergoes for tautomerization reaction. Already you know what is the meaning of tautomerization. Okay. So further it will be tautomerize. And what is the meaning of tautomerization? Tautomerize means this hydrogen, or we can say this bond. Just a minute, I can show you. Okay. So in this, what is the meaning of tautomerization? This OH. So this bond shifted over here along with hydrogen, and this pi bond shifted over here. So hydrogen finally shift at CH2 carbon. So what product we obtain? That means we get CH3 because this hydrogen is now attached to this carbon CH3. Now it becomes single bond C double bond OH. So what product we are getting? Aldehyde. And what is the name of this aldehyde? Ethanol. Okay. So from hydration of alkyne, any alkyne when reacts with water in the presence of mercury catalyst and sulfuric acid to form aldehyde, ethyne forms aldehyde. Okay. While the rest of aldehyde, suppose this is example of, this is what? This is propine. Okay. But when you take other aldehyde, like suppose propine you are taking, then this is unsymmetrical alkyne, and hence there is a follow Markovnikov's rule. And according to Markovnikov, the negative part attached to that unsaturated carbon atom, which having less number of hydrogen atom. So this OH minus will be attached to this carbon, and H plus will go to this carbon. Okay. So what you're getting the product? CH3, C, OH minus will be attached to this carbon, double bond CH2, right? And again, what will happen? Tautomerization. And in this tautomerization, this hydrogen and bond will be shifted to this carbon. So finally, what we are getting after tautomerization? So there is again tautomerization occur. And when we tautomerize, it will be for tautomerize to give what product? Yes, CH3, now it becomes C double bond O CH3. So there is a formation of propanone. So propine to propanone. So if in exam it is coming convert propine to propanone, so simply you can add water in the presence of mercuric and H plus catalyst. Okay, this is called acid catalyzed reaction. So what you are observing ki, even I have written over here, all alkynes form ketones, all alkynes form ketones except ethyne, because only ethyne can form aldehyde, that is ethanol. So when alkyne undergoes for hydrolysis reaction in the presence of mercury catalyst and in acidic medium, always we get ketone except ethyne. Okay. So these reactions are important for any conversion even also. So we are getting ketone. Is it clear? Okay. So the next is from alkenes. In alkenes, there is a two reaction. One is the ozonolysis, which you already read in class 11th and in the chapter, previous chapter also. Okay. So what is ozonolysis reaction? All of you are aware about this. Again, I'm repeating. So in ozonolysis reaction, what happens? This alkene, what is ozonolysis reaction? Alkene reacts with ozone to form first triozonide in the form of hut, which I am not making. And then further it is treated with zinc and water to give final product, which is aldehydes or ketones, or maybe same, maybe different. So, so what is this reaction? Basically alkene, this double bond gets cleaved, and at both carbon, the oxygen attached, right? So what product we are getting? So we get C double bond O plus C double bond. So we are getting two products, this one product and this two products. Okay. So this is the first product. This is the second product. Okay. Now it depends whatever the group attached over here. If suppose here the group is whatever the group, suppose it is H, it is CS3. Okay. Or suppose, okay, suppose here is any alkyl group, or here is hydrogen. So again, we get RH. Means if at this carbon any hydrogen is attached, so we get aldehyde. But if suppose there is a alkyl groups, both carbons, both having RR dash group, so in that case, what we get? Ketone. So by this method, we may get aldehydes, we may get ketone, or we may get both aldehydes and ketone combination mixture. Okay. So this is one example, just I've written. Suppose this is ReCH3, this is H, and this is CS3, CS3. So we are getting what product? Tell me the product. Yes. So we get CS3CH because the bond will be cleaved from here, and at both carbon, the oxygen double bond, oxygen will be attached. So we are getting this C double bond O, and at the second carbon also C double bond O. Okay. So we get one product is what? What is the name of this compound? This is ethanol and this is propanone. Okay. Suppose in ozonolysis products are given and you have to identify the alkene. So how you can identify the alkene by ozonolysis reactions if the products are given? Okay. So very simple, you can easily identify. How you can identify? Yes, you can write. Okay. So see how you'll identify, you can write. Suppose this is 2-propanol. So simply what you'll do, just you remove oxygen. Okay, I'm again writing over here, but you can see once again. So how we write the product? CH3, CH2, CHO. Okay, this product is given CHO. Plus another product is given, that is CH3CO. I am just writing CO in front of this. CO, CH3. Suppose this is CS3. So we can write CS2, CS2, CS3. So what you'll do for this, you can do one thing. What you'll do over here, just you remove both oxygen. You can remove both oxygen, and so both oxygen can be removed and these two carbon will be bonded by what? Double bond. So simply what you can do, you can remove this both carbon and then both will be, both oxygen carbon will be bonded by double bond. So by this, you can simply identify the product and then you can give the numbering. Okay, I'm just writing by white pen only. Okay, so you just remove both oxygen and join by the double bond and then select the long chain and counting from the lowest side of alkene. So you can count 1, 2, 3, 4, 5, 6, 7. So what is the name of this compound? This is called 4-methyl heptane, hept 3 in. So you can identify the name of the alkene also. So if the products are given, you can identify alkene. If alkene is given, you can write the product. So this method is called ozonolysis of alkene. Okay, we can see more example. Okay, you can see this also. Okay, I've given. Tell me what reaction will occur. Okay, you can cleave where? Yes, this double bond can be cleaved. This double bond will be also cleaved. And at all this double bonded carbon, we can keep oxygen. So what product we'll get? One product we get this. One second product we get this. Third product we get this. So what we are getting, we can write the product. CS3, CHO. This is the first product. What is the second product? CO, double bond O, we can write CS3, C double bond O, CH3. This is the second product. And what is third product? You can see CH3. This is the third product. Okay. CS3, CS3, double bond O. So how many products we are getting? 3 products. So if in a compound where there's 1 double bond, 2 double bonds, 3 double bonds, you can cleave everywhere. So you can write the name of the product also. This is ethanol, this is propanone, this is 1, 2, 3, 4. We can say pent 2, 3 dione. Okay. So this is the one example. Similarly, you can see the another example. Suppose this is the benzene. How you can write the reaction for benzene ozonolysis reaction. In benzene, 3 double bonds are there. So all double bond will be cleaved. This one will be also cleaved. This one will be also cleaved. And each carbon is what? CH. Each carbon is CH. This is all are CH. So what products will get it? And I told wherever the cleave, you can put everywhere oxygen. Here, here, here also, here also, here also, here also. So what you're observing, this is one product. Okay. So this is one product. This is another product. And this is another product. But all products are similar. So what is this? One product, two products, three products. So what is the first product? That is CHO. What is the second product? That is also CHO. What is the third product? That is also CHO. So here we are getting 3 moles of CHO. What is the IUPAC name of this compound? This is ethane 1,2-diol, and the common name is called glyoxal. Glyoxal, we can say it is common name. Now there is a one more example. I think that now it is clear to all of you. What is the name of this compound? Orthoxylene. Okay, what products you'll get it? Okay, first I will cleave from all double bond. Okay, and after cleavage, you can write everywhere. This carbon is, this is carbon, this is CH, this is CH, this is CH, this is CH, and this is carbon. And everywhere you can put what? Oxygen. This is one oxygen. So CS3CO. Here also we can put one oxygen. Everywhere we can put one oxygen, right? So what you're getting the product? Tell me. Yes, this is one product. This is second product. And this is third product. First, second, third. Tell me the first product. The first product which we are getting, that is what? CH3C double bond O CHO. Okay, this is the first product. What is the second product? That is also same. CS3 C double bond O CHO. So both first and second products are similar. Okay, so we can write 2 moles also we can write. Plus, what is the third product? That is CHO. This is third product. So very easily you can identify, you can write any ozonolysis reaction even also. Okay. Now in alkene, there is a second reaction of alkene, that is an oxidation of alkenes, but there are some conditions which you have to see. Okay, so this is one example of alkene. What is the name of this compound? 1, 2, 3, 4. That is, we can say 1, 2, 3, 4. Okay, this is 2-methyl bute 2N. Okay, so what will happen when alkene undergoes for oxidation reaction with strong oxidizing agent, that is alkaline KMnO4. So when you add alkaline KMnO4 and you heat the alkene double bond will again here also cleave, and again same thing at both carbon we get the oxygen. So what you're observing, what product we are getting? The first is what? CS3 CHO. Okay, so you know this is aldehyde, and aldehyde further oxidize because KMnO4 is very strong oxidizing agent. This is the reason the aldehydic group further oxidize into acid, that is carboxylic acid. So we not get CHO. So if double bond carbon having one hydrogen, so that will convert into aldehyde, but final product which we get, that is acid. So this carbon get oxidized into carboxylic acid. So what product get? We will not get aldehyde, but we get what? It's carboxylic acid, that is CS3COOH. So this is the first product which we get it like this. This is the first product. And the second which we are getting, that is CS3 C double bond O. This is ketone, and you know ketone cannot oxidize further. It can oxidize with a very strong oxidizing agent, but cannot oxidize by this KMnO4 also. So we get ketone. So if alkene will undergoes for oxidation reaction with alkaline KMnO4 in a hot and alkaline KMnO4, then in that case we can get ketone or we can get acid. Maybe both will be acid, maybe both will ketone. If suppose instead of hydrogen there is any alkyl group, then that will be ketone, right? Now you can see one example. I have given this one more example. This is a one example. This is a second example. You can see what happens in this case. This double bond cleave, and this is CH carbon. I told CH means aldehyde, but that will convert into what? Acid. So if CH is there, then we get carboxylic acid. So this CH group convert into COH, and then we can write like this, and second CH also convert into carboxylic acid. So what is the name of this compound? 1, 2, 3, 4, 5, 6. What you can say? What is the name of this compound? This is called hexane. So sorry, hexane 1,5 dioic acid. Is it clear? Okay. You can see this one also. In this case also the double bond cleave, but this carbon, so it will be formed ketone, but there is a CH, so this one form what? Acid. So what the product we will obtain over here? So this is acid, and here we get ketone. Like this we get this product. So you can write the IUPAC name of this compound. Even also, what is the name of this compound? 1, 2, 3, 4, 5, 6, 7. Okay. So what is the name of this compound? What we'll write? It is called, we can write 6 oxo or 6 keto hept heptanoic acid. So you must know how to write the IUPAC name also, because this is a drawback of the students. They don't write the IUPAC name. But if your habit will be maintained, always you write the IUPAC name of the reactant or products which you're obtaining, then never ever you'll face the problem during the exam to write the IUPAC name. Then it will be habit. You will be habituated. So you will always write the correct answer in the exam even also. Otherwise, what happens? You don't write the correct IUPAC name in the exam. Okay. So I hope it is clear. So what we have discussed. So this is clear. So now we can go to the next. This is from alkene, just we have discussed. So what we have discussed, again, we can see. First is from oxidation of alcohol. 1 degree alcohol forms aldehyde, 2 degree alcohols form ketone in presence of PCC and copper 573. Alkyne, when alkyne undergoes for hydrolysis reaction with mercury 2 plus and H plus catalyst, we get what? Carbonyl compound. Mostly we get ketone. Only ethyne can gives aldehyde. When alkenes undergoes for ozonolysis reaction, then the double bond cleave and we get the ozone aldehydes and ketones product, depends whatever the compounds are there. Okay. And when alkenes undergo for oxidation with alkaline KMnO4, hot and concentrated alkaline KMnO4, then the double bond cleaves to form ketone if there is a alkyl group, but if there is a CH group, then we get the carboxylic acid, right? This KMnO4 actually hot and concentrated. If the alkene will be dilute, if suppose we take the dilute KMnO4 like this, which I have written, okay. So when we are adding hot and concentrated alkaline KMnO4, then the bond is cleavage over there and we are getting this product. One is a carboxylic acid and another we are getting ketone, right? But if the same reaction occur in presence of not concentrate, but when the same reaction occur in presence of dilute and cold KMnO4, then in this case, the bond will not cleave. Then in this case, we get diol, means at both double bond carbon, the double bond will be cleaved, and both carbon, what group will come? OH group will come. That means we get the vicinal diol. Okay. And this reaction is actually, this is called Bayer's test. This is Bayer's test, which is used for unsaturation test. So this is called Bayer's test, which is used for unsaturation test. Well, all of you know what is the color of KMNO4? Purple color. And when this purple color, or we can say pink color, added in any alkene, it get decolorized. So this purple color become colorless. Okay. So this shows that this given compound is what? Unsaturated compound. And this is called Bayer's test. Okay. So now we can go to the next, that is hydrocarbon. The fourth point of hydrocarbon is from toluene. It is a part of hydrocarbon. We can say from toluene also. We can say from toluene we get what type of aldehyde? Yeah, we get aromatic aldehydes. Okay. So in this case, we get the aromatic aldehyde. What is this reaction? In this also, there's a three reactions. First is the means from toluene, we get benzaldehyde by three methods. First is using chromyl chloride, which is called Attard reaction. This is a name reaction. So what is Attard reaction? Attard reaction is a conversion of toluene to benzaldehyde in presence of chromyl chloride oxidizing agent, which is followed by hydrolysis. So you write the reaction toluene plus CrO2 Cl2 to form complex, intermediate complex. You can see CHOCrOH Cl2 whole twice, and this complex further hydrolyzed in acidic medium to form CHO, that is benzaldehyde. So Attard reaction, if in exam you don't want to write this intermediate complex, or might be you are thinking you made wrong, so then simply instead of complex, or in spite of complex, you directly write, okay, suppose you don't want to write the intermediate form, then how to write the reaction? Then you can write toluene, chromyl chloride, and in the same step, you can write this hydrolysis, and you can write the product, that is benzaldehyde, okay? So any method you can apply, okay? So this is the same reaction. Either you can write in the step form, or you can write the direct also. So this is Attard reaction. Now from toluene to benzaldehyde, one method is a Attard reaction, that is chromyl chloride. Second method, we can use CrO3 as oxidizing agent in presence of acetic anhydride. So second method, from toluene to benzaldehyde, we take toluene, CrO3, acetic anhydride. Here also we get the intermediate complex. And what is the name of this complex? Benzylidene diacetate. So we get intermediate complex, that is benzylidene diacetate, which further hydrolyzed CHOCOCH3 whole twice, which further hydrolyzed in acidic medium to form CHO, that is benzaldehyde. Okay. So there is one question, the reasoning question comes, ki what is the role of acetic anhydride in this reaction? Or we can say, why acetic anhydride added from oxidizing toluene to benzaldehyde using CrO3? So what is the use of this acetic anhydride? Okay. And what will happen if we will not add it? Okay. Suppose if we'll not add acetic anhydride, then this benzaldehyde further oxidize into benzoic acid. Okay. But we have to prepare benzaldehyde. So to prevent the further oxidation of benzaldehyde to benzoic acid, we use or we add acetic anhydride. So you can see the answer. What is the role of, or why we add acetic anhydride in this reaction? Because acetic anhydride is used to prevent the further oxidation of benzaldehyde to benzoic acid. To prevent the further oxidation of benzaldehyde to benzoic acid by forming to prevent the further oxidation of benzaldehyde to benzoic acid. How? By forming this benzylidene diacetate intermediate complex, which is non-oxidizable, and hence it can further only hydrolyze to give benzaldehyde. Is it clear? No. Okay, repeating. Why we add? Yes. In toluene, when we add CrO3, we also add acetic anhydride. Why we add acetic anhydride? क्योंकि ये acetic anhydride इस toluene के साथ intermediate complex बनाता है, that is benzylidene diacetate complex बनाता है, which is non-oxidizable होता है, and which cannot be further oxidized but only can be hydrolyzed to form benzaldehyde. Otherwise, what will happen? If we not add acetic anhydride, this benzaldehyde further oxidizes into benzoic acid. So this is the reason that acetic anhydride is added in this reaction to prevent the further oxidation of benzaldehyde to benzoic acid by forming non-oxidizable and intermediate complex. And this intermediate complex only can be hydrolyzed to give benzaldehyde as a final product. Right? Clear? Okay. By toluene, we can get benzaldehyde by very simple reaction also, that is chlorination in the presence of sunlight. So you know there's a nucleophilic substitution, sorry, there's a free radical substitution reaction occur. So this hydrogen substituted by Cl, if we'll take 1 mole, then we get CS2Cl. If we take 2 moles, then again one hydrogen will be replaced and we get CHCl2. That is benzylidene dichloride, right? And this benzylidene dichloride further hydrolyzed to form CHO, that is benzaldehyde. So from toluene to benzaldehyde, three reagents can be used, either Attard reaction, that is chromyl chloride, and followed by hydrolysis, or second by using CrO3 acetic anhydride followed by hydrolysis, or by Cl2 sunlight followed by hydrolysis. So from toluene to benzaldehyde, we can get by three methods, by three different type of reagents. Is it clear? Okay. So now this is one more reaction, that is Gattermann-Koch reaction. Okay. By Gattermann-Koch reaction, also we get what type of aldehyde? Aromatic aldehydes. So what is this reaction? Gattermann-Koch reaction is the reaction of benzene with CO and HCl in presence of anhydrous AlCl3 to form benzaldehyde. So there is also formation of benzaldehyde. And this reaction mechanism is actually similar to Friedel-Crafts acylation. Okay. So basically its mechanism is Friedel-Crafts acylation. Why we can say it is Friedel-Crafts acylation? Actually, COHCl is what? HCOCl. Okay, but you know it is not stable, so it decomposes into what? CO and HCl. Okay, so Friedel-Crafts, it was not explained by Friedel-Crafts, so it was explained by Gattermann-Koch reaction, but the mechanism is acylation mechanism. Okay, because this is acyl group, HCO is the acyl group, so mechanism is similar to Friedel-Crafts acylation. So when we are discussing about Friedel-Crafts acylation or benzoylation, so again, you have read in class 11th also and so many times in class 12th also, because this is a very common reaction. So what is Friedel-Crafts reaction? Already you have read it. Okay, benzene reacts with acyl halide, that is we have taken one example, acetyl chloride. So benzene reacts with acetyl chloride, that is CS3COCl in presence of anhydrous AlCl3 to form this acetyl groups come on the benzene, which is called acetophenone. So, or we can take when benzene react with, this is acetyl chloride, but when we take benzoyl chloride, that is benzene COCl, we get same reaction, but here what we are getting, this two benzene ring will comes on this, and this is called benzophenone. I hope it is clear to all of you. So what is Gattermann-Koch reaction? Benzene to benzaldehyde. What is Friedel-Crafts? By this reaction, what we obtain? We get ketone, not aldehyde. So today's class, I'm just over. Okay. So next class, we'll discuss the next topic. So please, all of you come with revision.